Hello viewers, welcome to my channel Civil Engineering. Today I will discuss with you a problem involving catenary which is non-symmetrical. Before solving this question, you have to subscribe my channel and press the bell icon. So viewers, it is a very important question for the civil engineer. First I will read the question and draw the picture of this catenary to solve the question one by one. Let's do it viewers. A flexible cable weighing 3 pounds per feet is strung between two supports. One support is 100 feet higher than the other and the sag measured from the lower support is 50 feet. The tension in the cable at upper support is 15,000 pounds. Calculate the following. The first question is distance between the two supports. Second, minimum tension in the cable. The third question is slope in degree at upper support, and the last question is length of the cable. Viewers, first question is distance between two support. So solution 1, I will draw the catenary first. This is the catenary viewers which is non-symmetrical, and it is the lower point of this catenary and it is the higher point of this catenary. It is also called upper support and it is also called lower support. And viewers, assume that this is the road bed and this is the hanger by which the cable is hanged. This is the hanger. And the middle of the hanger is called K. The middle of this hanger is called K. It's mean from this point to this point the distance is called K, and the sag measured for the lower support D equal to 50. It's the sag for the lower support, and also upper support is 100 feet higher than the lower support, 100 feet. So upper support is 100 feet higher than the lower support, and that is why the sag D prime for the higher support equal to 150 feet. And viewers, this point is P, this point is Q, and this point is O, and this point is M, where MQ equal K plus 50. Viewers, from this point to this point, this distance is called Y, which is equal to MQ, and also from this point to this point, this distance is called Y prime equal K plus 150. Viewers, we have to determine the distance between this point. It's meant AP distance plus BQ. So we have to determine the distance of AP and BQ. Viewers, we can write for the catenary the maximum tension F for the upper support, F equal to WY prime, and we know that F equal 15,000 pound and W means the weight of the cable per feet, which is equal 3 pound per feet, and we put the value here to get the value Y prime. 15,000 by 3 equal to 5,000 feet. Viewers, we know that Y prime equal to K plus 150. So K plus 150 equal to 5,000 feet. where k equal 4850 feet. Viewers, we can write for the catenary AP equal to x. AP equal to x. So we can write AP equal to x. And we know that for the catenary the equation y prime equal k cos hyperbolic x by k, and we know the value of y prime, the value of k, and we have to determine the value of x. So we will put the value here. X is to be determined 4850 and x equal 1203.14 feet. So guys, this distance is from A to P equal 1203.14 feet. And now for the same catenary, the equation of this catenary for y equal k cos is x prime by k, where BQ, that is point Q, and the point B, the distance of this point is called x prime. So we can write y equal k plus 50 and k is 4850 cos hyperbolic x prime is to be determined, and 4850 by solving this we can write x prime equal to 695.82 feet. This k equal, so it is equal 4900. We can write x prime equal to 695.82. Here we get the value of AP and the value of PQ, so we can add this value to get the distance between A and B. 1203.14 plus 695.82, which is approximately, guys, 1900 feet. So the distance between A and B is 1900 feet. Guys, second question is minimum tension at the cable. Let's solution to, I will draw the picture of this catenary again. This is the catenary which is non-symmetrical. This is non-symmetrical, guys, sorry. It is non-symmetrical and the point is lower and the point is higher, and it is the lowest point of the catenary which has a minimum tension Q. And we know that for the catenary Q equal to W K, where W is the weight of the cable per feet and K is the distance between this point to road bed. This distance is called K, and we know that W equal to 3 and K equal to 4850, and by solving this we get 14550 pound, and it is the answer. And the minimum tension for the cable is 14550 pound. Guys, third question is slope in degree at upper support. So is solution of 3. I will draw the picture of this catenary again, which is non-symmetrical, and it is the lower point B and it is the higher point, and there is the tension, and this point and this angle is theta. We have to determine the angle theta, where there is a minimum tension Q and there is a maximum tension F. We can write that from this catenary F cos theta equal to Q and F sin theta equal to W S. S is the length of the of the cable, this length, and W is equal the weight of the cable per feet, and we have maximum tension F, which is 15,000 pound, and Q equal 14,550 pound. So we can put the value to this equation 1 to get the value theta. F cos theta equal Q, and theta equal cos inverse Q by F, where cos inverse Q equal to 14,550 divided 15,000, and we got the value of theta is 14.06 degree. So this theta is 14.06 degree, and we get the value theta 14.06 degree, and it is the answer, guys. The last question is length of the cable. So guys, solution for I will draw the catenary first. This is the catenary which is non-symmetrical, and it is the lower point, and it is the higher point which is also upper support, and it is lower support, and there is a minimum tension Q. It is the sag for lower support D equal to 50, and also this distance is 100 feet, and the sag for upper support is 150, and we know the value of AP equal 1203.14 feet, and this distance BQ x prime equals 695.82 feet from question 1, and we have to determine the whole length of the cable. This point is O, guys, so we have to determine AO and OB, the total length of this cable. So we can write AO equal S and OB equal S1. We know that for the catenary we can write S equal K sine hyperbolic x by K, and we put the value here to get the value S, where K equal 4850 from question 1 sine hyperbolic, and X for upper support is 1203.14, and K is 4850, and by solving this we get the value of S equal 1215.51 feet. So we get the value of S is 1215.51 feet. And again for the same catenary we can write S1 equal K sine hyperbolic x prime by K, and we have the value of K and x prime. We can put the value here to get the value S1, and K is 4850, sine hyperbolic x prime is 695.82 feet and 4850. By solving this we can write 698.2 feet. So guys, we have got the value of S1, and now we can add this value S and S1 to get the whole length of the cable. So we add the value S and S1 to get the whole length of the cable to equal, and it is 1913.71 feet.